Okay, Workplace 11. Here's our third lesson in Chapter 1. We're going to talk about slope today. Now, that might seem a lot different than what we've been doing. We've been doing ratios and rates and proportions, and then boom, suddenly we're talking about slope. But here's the reason it makes sense. It's because a slope is a ratio, there you go, it's a ratio of rise to run. Wait a minute, what are we talking about here? When we're talking about slope, we're talking about how steep things are, right? How slanted something is, how steep something is. So if we just go down here, I got these two lines I've drawn here. They both have a certain steepness to it. Think about riding a bike. If you're approaching from the left-hand side, you do a lot more work traveling up this one than you were going up this one. How come? This one is steeper. This one has a bigger slant. And the way we measure slant, or steepness, is by looking at the ratio of rise to run. Now what does that mean? Rise is the change in vertical distance, and run is the change in horizontal distance. Okay, if you compare those things, how far something's changing vertically, now we're good with our vertical and horizontal, right? Vertical is up and down, and if we compare that to how fast it's changing horizontally, left and right, we'll get a sense of our slope. So I'm kind of doing this out of order here, but what the heck. If I look at this first line right here, I can pick any 2 points on that line to figure out the slope. Okay, it doesn't matter where I pick. I'm just going to very arbitrarily pick that point. I can pick any other point I want. I don't know, I'll pick this one. Alright, if I want to get the slope, what I have to do is compare the change in vertical and the change in horizontal. So in other words, what I would do, maybe I'll use lines for this, I would look from this point to that point, how much do I go up and how much do I go across. I need to get those two measurements, and once I had those two measurements, I could get the slope. So, I'm going to amaze you here. I'm going to pull up my ruler. Here it is. So if I want to measure this distance, I'm measuring the run, right, from left to right. So I put the ruler right at 0, and oh, that's pretty good. I just, arbitrarily pick those points, and it looks like I have exactly 3 centimeters. Or I could do it in millimeters. 3 centimeters is the same as 30 millimeters. I think I'll go with that. I'll go 30 millimeters. Okay, then what I have to do is I have to measure the rise, right? The up and down amount. So this amount right here. Now give me a second to fix my ruler. Okay, there we go. So if I put the 0 there, it looks like it's at, let's see, here was 10 millimeters, 11, 12, 13, 14, 15, 16, 17? I'm going to say 17. It might be 16 in a bit, but I'm going to say 17. We're just trying to get a sense here of what we're talking about. So this is 17 millimeters. So if we wanted to talk about slope, what we would do is look at the ratio of the rise. Remember, the rise was 17. So the slope is equal to 17, that's the rise, and the run is 30. Notice I don't put any units because the slope is a ratio, and with ratios it has the same units, millimeters, so they just kind of cancel out. So this would be your slope. Now we don't usually express it that way. We usually do it as a decimal or fraction, so we'll do that in a second. Let's go back and talk about some of the things I've already mentioned now. So slope does not have units. I just said that since it's a ratio. And it usually is expressed as an integer. So for example, you might actually get that the slope is 5, for example. That could be the slope. Or the slope is 2. Or even -3. We'll talk about negatives at a future lesson. So it can be an integer, it could be a fraction, like whatever we just got. What do we get? 17 over 30. So instead of writing 17 colon 30, you would probably write 17 over 30. Or the other way you could do it is as a decimal. So for example, our 17 over 30, I could literally divide 17 divided by 30, and I get 0.17 5, 6, and the 6 is repeating. So these are all different ways of expressing the slope. Of course, this 5 has nothing to do with the line we just did. I just want to give an example. All right, so that takes us to the formulas for slope. So I'll write those in the box here. Slope is equal to rise divided by run. So that's absolutely what we did right here. I mean, I can show it as a division statement. We took our rise, which was 17, and divided it by our run, which was 30. And then, as I said, you have a choice. You can leave it as a lowest terms fraction, and this is in lowest terms, so that's good. Or you could actually divide 17 by 30, and you get whatever answer I said before. What did I say? 0.56 repeating. Okay, so that is one way you can get the slope is rise divided by run. The other way you can think of it is it's the triangle. What's this triangle all about? Anyone taking physics this year? Triangle refers to change in. It's just a fast way of saying change in. So the other way you can get the slope, it's the change in the vertical distance. Well, the change in the vertical distance was 17 here, divided by the change in the horizontal distance. Well, the change in the horizontal distance was 30 there. Okay? Is it necessary to do another one here? What the heck? I'll do one more. I want to show you, again, as I said before, should the one I'm going to do right now, should it have a bigger slant than the one, bigger slope, sorry, than the one I did before, or a smaller slope? Should have a smaller slope. It's not as steep, so it should be smaller than 0.56. Let's see if that's the case. So the first thing I want to do is I want to pick any 2 points on this line here. It doesn't matter. I could do them right beside each other, or I could go really far apart. Let's go really far apart. It's more fun, right? Okay, now I want to draw some lines here. There's 2 ways you could draw the lines. You could rather go up here and over. That's what I did here, right? Up here and over. Or you could draw the over part first. It really doesn't make a difference. And then here's the up down part there. Okay? So it doesn't matter if you draw the triangle. You see you get a triangle here. You could draw it at the bottom or you could draw it on the top. I usually draw it on the top like this, but it doesn't actually matter. Okay, now what I need to do is I need to measure the rise and the run. Let's do the rise first. So I bring my ruler over, set it up at the 0, and what do I get? I get, here's 10 millimeters, 11, 12, 13, I would say 14 millimeters. So I'll write that in there, that it is 14 millimeters. And then give me a second again to switch the ruler around. It's actually really easy to switch, I just always forget how to do it. Okay, then I put the 0 on that dot and I measure over, what do we got? 70 millimeters, and then 71, 72, 73, 74, 75, 76, 77. Let's go with 77 millimeters. So I'll put that here, 77 millimeters. How do we get slope? In case you don't remember, I'll write the formula. It's rise over run. Well, our rise amount is 14 millimeters, and our run amount is 77 millimeters. Again, look, you got the same units, so those units just cancel right out. So this could be your answer right there. The slope is 14 over 77. But it's hard to compare 14 over 77 with 17 over 30, is it? It's hard to tell which one's bigger unless you're really good with fractions. So let's switch this 14 over 77. Let's switch that into a decimal. Remember how to do that? You literally just divide. Remember, this line in a fraction means divide. So 14 divided by 77. By the way, I just realized this. I could have put this in lowest terms, and I should put it in lowest terms if I'm going to keep it as a fraction. It's kind of a hard one, but 7 goes into both of these. 7 goes into 14 2 times, and 7 goes into 77 11 times. In other words, you can divide both of these numbers by 7. I'll put that there if it helps you understand what I'm doing. Okay, but again, that leaves us with a fraction that's kind of hard to compare to the 17 over 30. So let's do 2 divided by 11 and see what we get. We get 0.18, and it's all repeating. And so, sure enough, what's bigger, 0.56666 or 0.181818? This is bigger, the 0.56. It's steeper. It has a bigger slant. This has a smaller slant. Okay, let's answer a few more questions. I'm going to write the formula in the corner here because this is basically what you're going to use for all of these. Slope equals rise over run. So let's see what we got here. Calculate the slope of a line that has a rise of 12 and a run of 8. Oh, not bad. We're just going to use that formula. Why did I bother writing it over there? I'm just going to write it again here. That was kind of silly. Rise over run. So what's the rise number? The rise is 12 centimeters. What's the run number? The run is 8 centimeters. You can get rid of the centimeters because they're same units, right? If one was centimeters and one was meters, for example, you'd have to switch meters to centimeters or centimeters to meter. But once you have them the same units, it's a ratio. That's what we want. We don't need to write the units anymore. Okay, this is an answer, 12 over 8. It's not the greatest answer. How come? You can still leave it as a fraction, but make sure it's in lowest terms. What can you divide 12 by and also 8 by? What number goes into both of them? 2 is good. If you said 2, it's actually a bigger number. 4. Divide them both by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Okay, so that's one very acceptable answer. You could say that the slope is equal to 3 over 2. Or you could take your calculator and divide 3 over 2, 3 divided by 2, and you'll get 1.5. So either of these answers are great for expressing the slope of the line. Okay, the next one's a little different. This time they give you the slope, and they give you the run, and you have to find the rise. All right, I'm going to move this equation down here. It's going to be useful here. So we know the slope is 7 over 20. So where it says slope, guess what we're going to write? 7 over 20. So I have 7 over 20. I'm just replacing the word slope with 7 over 20 equals rise. Do we know the rise? No. It says what is the rise? We don't know the rise. So I'll put a big R here for rise. If the run is 100 meters, so the run is 100 meters, that goes here. How on earth are we going to figure this out? It looks a lot like a proportion. Two fractions that are equal to each other. There's only one thing we don't know, which is the R. Let me get rid of this M. I don't want to confuse you. Those are just units. So how do we solve this? We cross multiply. So you look to see which is the diagonal where you know both numbers. You do not know both those because of that R. So the diagonal you have to start with is this one. So how do we do it? In order to find R, we're going to multiply 7 times 100, and then we're going to divide it by the number which is left over, which is the 20. And if you do that, you're going to find that R is equal to 35. 35 what? What were we talking about again? Well, remember, this was 100 meters here, and in a ratio the units don't change, so this would also be meters. 35 meters. The rise, how much it goes up, is 35 meters. Okay, the next one's very similar, except this time you're looking for the run, and in this one we were looking for the rise, but now we're looking for the run. But it's really just the same sort of thing. So let me move our formula down. The slope of a line is 3.5. So we can put 3.5 equals, right? We just replace slope with 3.5. The rise is 14. So our top number is going to be 14. And our bottom number, the run, we don't know. That's the thing we're trying to figure out. I don't know. I'll put n this time. Now, this is kind of weird because it's a proportion, but there's no number down here. If there's no number on the bottom, do you know what number you can always put? You can always put the number 1. Putting anything over 1 doesn't make a difference. Because think, if you put it over 1, it means divide by 1. And when you divide anything by 1, it doesn't change. 5 divided by 1 is 5. 10 divided by 1 is 10. Sorry. 3.5 divided by 1 is 3.5. So if you ever get this situation you get confused because one of them is not a fraction, just make it a fraction with 1 on the bottom. All right, we're good to cross multiply now. What are you going to cross multiply? You're going to go 1 times 14. Oh, that's easy. And then you're going to divide by 3.5. And, oh, that's nice. It goes in evenly, 4 times. So the rise is 14. It doesn't say what units are. It doesn't say if it's centimeters, meters, so we can't put units here either. We don't know what they are. So we'll just leave it like that. N equals 4. Last question. Find the slope of this line. All right, and they've put it on a coordinate plane. We'll be doing more of this in a couple more lessons. So remember what I did in the other page? I said that you could pick any points on this and draw your vertical and horizontal line. But does it make sense to you that picking this point isn't really the brightest point to pick, and this one's not the greatest point, and this isn't very good? Do you know why? because they don't line up perfectly with the grids, right? We want to pick some points which I call, they're not really called this, but I call them pretty points. Pretty points are points that land right on the intersection of any of the lines. Like this would be a pretty point right there because it's in the intersection of the grid lines. This is a pretty point. This is not a pretty point. This is not a pretty point. This is not a pretty point. That is a pretty point. It lands on the intersection. So what I would recommend you do is find any two pretty points on this line here. So I'll find all the pretty points if you want. No, 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 no. Yes, this is a pretty point. No, 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 no. Yes, I would call that a pretty point. No, no, no. Yes, that's a pretty point. And that's a pretty point. So you have 4 points. How many do you need to find the slope? 2. Pick any 2 you want. You could pick this one and this one, or this one and this one, or this one and this one, or this one and this one, this one and this one, or this one and this one. So what's that give you? 6 possibilities? So I'll pick this one and this one. How about that? Okay, so what are we going to do? We're going to draw that little triangle, right? We're going to think of the up and the over, the rise and the run. So I'll start at this one and I'll draw a line rise. How far do I go? Right to there, because that's where the other point is. And then I'll run from here to here. Okay? So this is good news. It's on a coordinate plane. You know why? We don't have to use that silly ruler. All we have to remember is that slope equals rise over run. So how far do we rise to go from this point up to here? We rise, don't count where you start, you rise 1, 2, 3, 4. You go up 4. Divided by the run. How far did you run to go from here to here? Let's count. 1, 2, 3, 4, 5, 6. 6 would be the run there. So there's your answer. The slope is 4 over 6. But I don't really like that answer. You know why? It's not in lowest terms. What could you do to put it in lowest terms? Divide them both by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. I just want to really quickly show you, I'll do this very fast. I want to show you that it didn't matter whether we picked those 2 points or not. We could have picked any points. Let's say, for example, that I'd picked this point and this point. Then my triangle would have looked like this. How much did I rise? 1, 2. How much did I run? 1, 2, 3. So I would have had rise over run, 2 over 3. Hey, that's what we got, 2 over 3. What if I picked this one and the one way up here? Well, then I would have had to rise all the way up here and then run all the way over here. How much is that? 1, 2, 3, 4, 5, 6. And I would have run 1, 2, 3, 4, 5, 6, 7, 8, 9. I would have gotten 6 over 9. You know what that is in lowest terms? 2 over 3. Divide them both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. You get 2 over 3. You always get 2 over 3 no matter which points you pick. You would even get 2 over 3 if you were crazy enough to pick a point like here and here, non-pretty points. And if you could figure out exactly how far the rise is and how far the run is, I promise you, you will always get 2 over 3 for any 2 points in that line, which is pretty cool. All right, everyone, that's your introduction to slope. We'll be talking about it for the next few days. Have a great day. We'll talk to you later. Bye.